today's problem from central orbit of particle dynamics, and the problem is a particle moves with central acceleration. This is given by mu into 3u square plus a square u to the power 5. Here the central force we write here, central force P. This is given by mu into 3u cube plus a square u to the power 5. This is the central force being projected from a distance a at an angle 45 degree with a velocity equal to that in a circle at the same distance. And we know that velocity in a circle, this is given by v square, this is equal to p into r, okay, where r be the radius of the circle. And here it is given that projected from a distance a, and here p is given by this. So velocity in a circle or initial velocity of projection is given by v square. This is equal to p. P means p, but we put u. This is equal to 1 by a, because here a, r equal to a implied u equal to 1 by a, and also r, this is equal to a. So we get mu into 3 by a cube plus a square by, this is a to the power 5, a to the power 5 into a, and this gives mu into 4 by a cube into a, that is 4 mu by a square, that is v. This is equal to root 4 mu by a square. This is the initial velocity, or it is given by 2 by a into root mu. Okay, this is the initial velocity of projection. And here the angle of projection, this is equal to phi, that is we get phi, this is equal to 45 degree, that is p, this is equal to r sin phi we know. So p0, this is the initial value of p, is given by a into sin 45 degree, that is a by root 2, right? Now also we get the another relation from differential calculus, 1 by p square, this is equal to 1 by r square plus 1 by r square dr d theta whole square, okay. And by putting the value of r equal to 1 by u, we get here u square plus, this is not 1 by r square, 1 by r to the power 4 dr d theta, and this is du d theta whole square, because dr d theta, this is equal to minus 1 by u square du d theta, okay. So we get here dr d theta whole square, this is equal to 1 by u to the power 4 du d theta whole square, and we put 1 by r to the power 4, this is u to the power 4. So we get this result. Now here we put the initial condition, we get initial value of u square plus du d theta whole square, this is equal to 1 by p0 square, because the initial value of initial value of p is p0, and putting the value of p0 square we put here, and this is given by 2 by a square, okay. We also use this result in our problem. Now we write the differential equation of central orbit with central force this, okay, and this is given by h square into u plus d2u by d theta 2, this is equal to p by u square. Actually it is p by h square u square, we multiply this p in here, okay. Now putting the value of p, we get mu into 3 u cube plus a square u to the power 5, by u square. Okay, and this is given by mu into 3u plus a square u cube, right? And the left hand side is h square into u plus du d2u by d theta. Now we multiply both sides by 2 into du d theta, and we get the result as h square into 2u du d theta plus 2 du d theta into d2u by d theta 2. This is equal to 2 mu into 3u plus a square u cube into du d theta, and integrating we get this is h square into the first term is u square plus second term is du d theta whole square, right? And this is given by 2 mu into 3u square by 2 plus a square u to the power 4 by 4 plus another integrating constant, this is a. Okay, and we know that in central orbit this is the expression of velocity, so we get this is v square, this is equal to h square into u square plus du d theta whole square. This is given by mu into 3 u square plus a square u to the power 4 by 2 plus a. Okay, we put the initial condition 1 by 1. We put here u, this is equal to 1 by a, this is initial condition. We put v equal to v equal to root over 4 mu by a square, this is another initial condition, and we put initially u square plus du d theta whole square, this is equal to 2 by a square. Okay, now from these two portions, first and second portion, we get this is v square, so initially we get 4 mu by a square, and this side is h square into the initial value of this portion is given by 2 by a square, and this is mu into 3 by a square plus a square by 2 into 1 by a to the power 4 plus a. Okay, we put in all the three initial conditions here, and from first two portion we get the value of h square, this is given by 2 mu. Okay, we get the value of h square, and from first and last portion we get the value of a, this is given by 4 mu by a square into minus, this is given by a square cancel out, so mu into this is 7 by a square. Okay, and we get 2a square, this is 6 plus 1 by 2a square the LCM, and this relation gives 8 mu minus 7 mu by 2a square, so mu by 2a square, that is we get a, this is equal to mu by 2a square, this is one arbitrary constant, and another arbitrary constant is h square equal to 2 mu. Now we putting the value of these two arbitrary constant, that is h square, this is equal to 2 mu, and a, this is equal to mu by 2a square in this final result or in this differential equation, and getting the value as this is 2 mu into u square plus du d theta whole square, this is equal to 2 mu into 3 u square by 2 plus a square u to the power 4 by 4 plus a, this is mu by 2 a square. We cancel out mu from both sides, and we write 2 in the lower side of right side, and this is 4, right? Now we let here u, this is equal to 1 by r, we already find this result, and this is du d theta, this is equal to minus 1 by r square dr d theta. Okay, we put this two result here. This is given by 1 by r square plus this is 1 by r to the power 4 dr d theta whole square, and this is given by 3 by 2 r square plus a square by 4 r to the power 4 plus this is 1 by 4 a square. Okay, and this relation gives 1 by r to the power 4 dr d theta whole square. This is given by 3 by 2 r square minus 1 by r square plus a square by 4 r to the power 4 plus 1 by 4 a square, and this is given by 3 by 2, that is 1 by 2 r square, right? 1 by 2 r square plus a square by 4 r to the power 4 plus 1 by 4 a square. Now we multiply r to the power 4 in the right side, we get dr d theta whole square. This is equal to r square by 2 plus a square by 4 plus r to the power 4 by 4 a square, and this is given by 4 a square into this is 2 a square r square plus this is a to the power 4, this is r to the power 4, so this is r square plus a square whole square by 4 a square. Okay, and this result gives this is dr d theta, this is equal to r square plus a square by 2a. Okay, 2a, this is plus minus. Now in central orbit we know that this is r square theta dot, this is a constant, this is given by h, we know it, and this relation gives r square into theta dot means d theta dt, this is equal to h, and sorry, this is d theta, this is h dt, this is equal to r square d theta. And to find the required time to reach at the center of force, we integrate this result. Okay, now before integrating this result, we write the result is this is h into dt, and the right side is r square d theta by dr into dr, we can write here. Now putting the value of d theta by dr, from this relation we get d theta by dr, and this is r square into 2a by r square plus a square, and we take here only negative sign into dr. Okay, now initially it is given that r equal to a, and at the center of force we know that r equal to 0, and let if capital T be the required time, then we integrate this result as h into integration 0 to capital T dt, this is equal to minus 2a into integration r square by r square plus a square into dr. The range is r equal to 0 to, sorry, r equal to a to 0, because this is initial position and this is the center of force, this is final position, and we write this integration as 2a into integration 0 to a. This is written by r square plus a square minus a square by r square plus a square dr, and this part is given by h into capital T, and this is 2a into integration 0 to a 1 minus a square by r square plus a square dr. This is 2a into, by integrating we get r minus a square into tan inverse r by a and also 1 by a, and the range is 0 to a. Okay, so this is 2a into a minus, this is also a into tan inverse, putting the value of r is a, we get 1, and for the lower value both the term are 0, and this is given by 2a square into 1 minus tan inverse 1, this is pi by 4. So we get a square into 2 minus pi by 2. Okay, so the required time t, this is equal to 1 by h into a square into 2 minus pi by 2, and putting the value of h, we get h square equal to 2 mu. So this is a square by root 2 mu into 2 minus pi by 2. Okay, so this is the required time. We want to prove this result, and this is the final result of the problem. Okay, this is very important problem of central orbit. Thank you for watching.